I met a traveler from an antique land who said, "Two vast and trunkless legs of stone stand in the desert. Near them, on the sand, half sunk, a shattered visage lies, whose frown and wrinkled lip and sneer of cold command tell that its sculptor well those passions read which yet survive, stamped on these lifeless things, the hand that mocked them, and the heart that fed. And on the pedestal these words appear: My name is Ozymandias, King of Kings. Look on my works, ye mighty, and despair. Nothing beside remains. Round the decay of that colossal wreck, boundless and bare, the lone and level sands stretch far away.
When does a language die? When its last speaker dies out, when the last child is taught, or when the last word is spoken one to another and understood. For a programming language, I think it's when the last line of code is written and run. And by that definition, Forth is far from dead. I personally have been keeping it alive these past few months with the fervour of a newly qualified paramedic chest pumping her first blue light patient. Not today, Forth, not today. But it is dying, or it seems to be. It was born in the 20th century, lives on into the 21st, but I don't know if it'll make the 22nd. Time will tell. I want these series of videos to be a kind of pre-eulogy or possibly revival of Forth the language. I want to talk about the language itself, its philosophy, its history, why we even talk about languages having a philosophy. After all, they are just technical tools. It is odd that we should consider them this way. I want to talk about Chuck Moore, about Dr. Chen Hansen Ting, and about Elizabeth Rather. I want to talk about why I had to begin this video with this cringe poem, why it makes sense. But I've come to the conclusion that to tell you all this, you're going to need to know just a little bit about Forth the language. I can't honestly recommend you learn it. I don't think it'll necessarily make you a better programmer. All it's done for me is occasionally I keep using Lukashevitzian notation in all the wrong places. I don't think you'll regret it, but equally I don't think it'll massively improve your prospects. But there is a lot we can learn from Forth, things that I want to tell you, now need to tell you, now that I've understood them myself. And to do that, I need to tell you about Forth the language. You need to understand a bit about how it works. So I'm going to start off with a short series of videos, each exploring a small Forth program. By analysing these, digging into them and seeing how they work, I hope you will gain some understanding of how Forth works, even if you don't necessarily understand how to write Forth. I do hope that some of you do find Forth an inspiration and go and learn it, and I don't think you'll regret it. I think you will learn a lot and you will really value the experience, but I don't think it's going to be that many of you, and that's okay. We'll start with our first program right now. This is a Forth program, a very small one. Every Forth program is a list of words, and this one has just two of them, over and star. Forth words operate on a shared stack, sometimes called the data stack, and we're going to start off with two items on the stack, which you can see here in orange. Now that we've got those, let's run it. Forth words are interpreted in sequence. First, we execute over, which copies the second item on the stack to the top of the stack. Then we execute star, which takes the top two items and multiplies them. By executing this tiny program repeatedly, we get 2, 4, 8, 16, 32, and 64, the powers of 2. If we do the same with 1 and 3 on the stack, we get the powers of 3. This tiny program computes exponentials. Sort of. I mean, we're deciding how many times to execute it. Really, we should use a loop for that. And Forth can do this. Forth has a looping construct called a do loop. To use it, you put two items on the stack. The top one is the starting number, and the second one down is the number to count up until just before. When do runs, it consumes these items and starts a counter. Every time the execution hits the loop word, the counter increments, and if that incremented number is under the limit, we jump back to the top of the loop. And when the incremented number equals the limit, execution continues past the loop, and since there's nothing more to do, our program ends. Our program can now calculate 2 cubed. But the parameters for our program are a bit awkward. Here we're calculating 2 to the power 3, but we're passing in 0, 3, 1 and 2. That 0 and 1 on the stack are really just details that our program should be dealing with, not whoever is using it. We should add them into our code and just ask the user to put in 2 and 3. Removing the 0 is easy. We just put a literal 0 into the program. When we run this program, the interpreter will observe that this is a number and place it onto the stack, just in time for our do word to consume it. The 1 is a bit more tricky. If we just plonk it on top, it'll interfere with our parameters to do and the program won't work anymore. However, if we follow our 1 with a swap, which swaps the 2 elements on the stack, then our stack items end up in the right place and our program works again. We can now pass it the base and the exponent on top. But we're still leaving an unnecessary value on the stack after our program is done. The 8 is good, that's just 2 cubed, but the 2 underneath it really shouldn't be there. We can get rid of this by swapping the items and then dropping the top one. This gets us our 8 alone, nice and clean. There's actually a single word in Forth that means remove the second item on the stack, and it's called nip, so we'll use that instead. Now our algorithm starts and ends cleanly, but there's still one problem. If we try to calculate the 0th power of a number, the program runs forever. Since do loop only checks whether the incremented counter is equal to the limit, if we give it 2 of the same number, then it skips over the limit and never terminates. Fortunately, there is a variant of do called question do designed for exactly this scenario. Question do checks if the counter and limit are the same at the start, and if they are, it'll skip the loop entirely. You might be thinking we need to explicitly check for this power of 0 case and return 1, but we don't. Since we start off with 1, multiplying our base 0 times will give us back the same 1 again, and this has actually been baked into our algorithm since it was the 2-word program over star. All that remains is to define our program as a new 4th word, equivalent to a function or subroutine in any other language. But we'll talk more about defining words in a future video. This word, which I wrote all by myself by the way, was the first word I wrote in Forth where I started to understand what it might mean to write good Forth. The Forth standard doesn't include an exponentiation word, at least not unless you want to implement the algorithms and floating point extensions, which I definitely didn't want to do, so I had to write my own. I spent a while muddling around with guard clauses for the 0 power case and trying to manipulate all the stack items to be in the right position, and it was a real mess. This, as you will probably come to learn, is a hallmark of what they call bad Forth. Too many stack manipulations cluttering up the code. I would try to reproduce it for you so you could see what a mess I made, but I actually no longer can. Forth does that to you. A few weeks ago I began to be able to see, visualize the top 3 stack items in my head. Where previously I'd have to, sketch things out or use code to prototype things, I can now just see them moving around. In fact, as I was writing this, I mentally constructed a pair of words which would swap the top 3 items on the stack, something which I definitely couldn't do a few months ago. And this is the first word that I wrote, or maybe even the first program I've written, that I thought maybe it had a little bit of what they might call beauty to it. It even taught me why something to the power 0 is 1. I mean, you start off with 1, you multiply it by the base exponent number of times, so it makes sense that something to the power 0 is 1. I'm sure there are other reasons, but it makes sense just looking at it now. I studied writing at university on an experimental performance writing course at a place called Dartington, a place where we would often discuss what counted as poetry. And at the time, and since, and after many attempts, I decided that code could never really actually count as poetic. It was too descriptively literal to fill that role. But this program, and Forth in general, has started to change my mind about that. And maybe if we were ever going to write poetry in code, Forth would be the language to do it, which makes sense because Forth is just words separated by whitespace. Remember that, it's going to come up a lot later. There will be a little series of these little Forth program/poems videos leading towards something bigger. I've also built a Forth IDE. It's not quite finished yet, but I've opened it up to ODES members. So if you're an ODES member or you want to be one, you can find the link to that as well as an exercise to play around with it on the page in the description. And thanks, by the way, for supporting the project and funding me working on the IDE and these videos for the last few months. When the IDE is finished, I'll open it up to the public web too. I'll see you soon when we'll examine another Forth program. Laters!